Look, does anybody need to get some fresh air before we start the second one? Because it's I think they are open. Are the windows open?
No. No.
Goodness sake. Open those windows all the way.
This is kind of the worst thing.
Perhaps.
Yeah.
There's a fan upstairs in B401, and you can bring it down, and then that, I think, will help a little. There's room directly upstairs, yeah. Okay, so let me just do those two homework projectile ones. A boy kicks a plastic bottle off a cliff which is 100 meters long. So the cliff is 100 meters.
It's the height?
It's the height of the cliff, yeah.
I think that don't be put that much.
Oh yeah, this is an exam topic, yeah.
Yeah. You're always standard.
Oh no, you don't have to draw it, it's just I find it helpful. He kicks the bottle at an angle of 30 degrees. And he kicks it with a speed of 20 meters per second. So in red here I'll put the two parts in. 20 cos 30, 17.32 meters per second, and then 20 sine 30, that's 10 meters per second. And my question is, how long until it hits the ground? What's the range and what's the maximum height? Oh, let the hat in. Oh yeah, now we're talking. Yeah, well, let's put it here in the center.
So we're using it for the
Who? Which teacher? All right. She doesn't like the room cold. She always wants it warm. Oh, thank goodness. Oh yeah. All right. This shall help.
That's not good.
Nice. Huh? This is better. Okay, so firstly, I would like I think I said the time. So should I look at the horizontal or the vertical?
Vertical.
Yeah, very good, the vertical. So let's look at the vertical.
Which question is
This is the projectiles one, the first one of the two. Yeah. Yep.
Two folds would be like, okay.
Two what?
Like,
you want the line down the middle? Yeah, okay. X and Y. Okay, so U, V, A, T, S. U is 10. B we don't know. A is minus 9.81. T we don't know. And what's S?
But 100 meters is this one.
This is 100 meters, yeah? What's S?
It's x over. It's what?
What is it? This is Y.
100. Minus 100.
It's minus 100. Okay, so which formula? Let's see. S equals UT will do it. Okay. S equals UT plus a half AT squared.
And what about the coordinate of the speed?
I already used that to make that horizontal and the vertical.
The how?
Yeah. Okay.
Time is equal to 3.
Now this type of problem, you've seen it in maths. What type of equation is this? No, what's it called? I want the name. What's it called? Quadratic equation. And you can use your quadratic formula from maths class to get the answer. So I got two answers. I'll just take the positive answer. 5.65 seconds.
Teacher, this is the S solid
Yeah.
minus 100.
Yeah.
How did you get it from?
This one? How do I get this?
S, yeah, this one.
It's given in the question. Yeah?
The high.
Is this okay? Yeah?
5, 10.
Is it not 10? I thought I typed it in right. This is 20, yeah?
Yeah.
And I say it's 30 degrees?
Yeah.
So this is 20 cos 30 and this is 20 sine 30. Did you use 20 here?
Yeah.
No.
I used 10, but I got this.
Which is
This is cos and this is sine.
why?
This is... Let me remind you why. This is A, this is X, this is Y, this is Z. So you know that cos A equals X over... No. So then X equals Z cos A.
You have one of the formula paper.
Yeah, I did this on a page.
Yeah, the small paper.
Yeah, you have this on your small card. Grace, what is sine A? Divide. So y equals Z sine A. This one here is Z sine A. And this one here is Z cos A. That's why it's cos and sine. Here. Okay? What do I ask for next? The range. So that's this distance here. Okay, so what's U? 17.32. B, A is 0, T is 5.65, and S is what I want. So S equals U, T. That's the S. Yeah. And then lastly, I want the height. So I want the maximum height, which I've drawn in green here. That's this height here. So do I need to look at X or Y if I want this?
Y.
Y, yeah. So what's the U? 10. What's the V for this one? Maximum height? What's the V? 0. What's the A? Is this enough information? Yeah. So I can now get the S. This S here.
As you get B equals 0?
It's maximum height. The V is always 0 at the top.
Okay.
Yeah. So I'll use S equals U. Which one will I use actually? V squared, yeah. V squared equals U squared plus 2AS. 0 equals 100 minus 2AS. So then S equals 5.1 meters. Is the maximum height. Range. Time.
Why the acceleration in range is 0?
Yeah. Horizontally, there's no acceleration. The acceleration is only vertically in projectiles. I'm going to do the second example, and then I'm not going to do the homework questions. I want people to try them again for next week. Now that you've seen 2 more examples, it might be easier. Yeah? I think it'll be better this way than me doing them again. I'll do them next week. Let's have a look at the second example. Right, so this one here, the boy throws a penny up in the air and then it goes straight down and splash. Splash, yeah. And we know that this distance here is 330...
26 meters.
No, sorry, we know that this here is 26 meters. And we know that it takes 7 seconds for him to hear the penny hit the bottom of the well. What we don't know is how fast he can throw the coin up in the air. So, do we know the U? No.
No.
Do we know the V?
Yeah.
No.
No.
Do we know the A?
Yeah.
Yeah. Do we know the S?
Yeah.
Yeah, what is it?
26.
926. And do we know the T?
The one, you know, the coin still goes up
Yeah?
before like more than height of the like.
Doesn't matter.
This is for
This is
why,
for
right?
right. Yeah.
Why?
Oh yeah, this is only vertical. There's no horizontal in this question. Yeah. Do we know the T?
Okay.
No.
7 seconds, right?
It's not quite 7. 7 seconds is how long until he hears it. So when you think about it, well, I'll wait till you're all ready because it's difficult. Okay, ready? So it takes him 7 seconds for him to hear it. So what happens is when the coin hits the ground, it takes some time for the sound to reach him. It's not instant. That 7 seconds is made up of 2 parts. The time, which is here, plus how long he has to wait before he hears it. For example, let's say it was 7 seconds. Maybe it takes 6 seconds to fall and then 1 second for the sound to go back to him. So, will it be 7? No. Will it be more or less than 7?
More than.
More than 7.
More than.
Now it is
Less than 7, because you have to take that time away. So now we need to know how long does it take for the sound to get from here to here. Well, the sound is a simple distance, speed, time triangle. Oops. Distance, speed, time. So time, distance, speed, time, that's the distance, which is 26, divided by 330. Because in the question I said the sound goes at 330 meters per second. Yeah. 0.0789 seconds. Yep.
You know, that's from where the well starts.
Yeah.
It is.
I know, we don't know how tall he is, so we're just making it approximate. If you want, you could say he's 1 meter tall and then you just make this 27. That's all. It's not going to change this much.
But no, I'm just saying when you think of a system in every sometimes.
Yeah. So what are you not happy about here?
No, I'm just saying the distance 26 is only of the well.
Yes, correct, yeah.
But the point you goes up 10%.
Correct, yeah.
So if you when you calculate the U, V or
Yeah.
so don't we need extra height?
Oh no, we do not. Because S, what does S represent? No. What does it represent for half? No?
Displacement.
Displacement. it's 26 meters below where he started. It's correct. You don't put the distance in for S. You put the displacement. Remember, I even gave you the warning on the board in red. S is displacement, not distance.
So the ball hits the ball,
Yeah.
and after 6 seconds he hears it.
After 7 seconds he hears
After
it,
7
yeah. And it takes this long for the sound to go up to his ear, so the time is 7 minus 0.0789, 6.9211 is the time. So now we know the time, 6.9211. Okay, so now we can get the U. We shall use, let's see, S equals maybe?
Yeah.
S equals U T plus a half A T squared. Okay, so we can say that if I just do minus 26 plus 9.81 over 2 times 6.9211 squared, take that over and then divide by 6.9211. Okay, that's the U. So let me just type that in the calculator. So the U is 30.2 meters per second. So that's how fast he threw it.
In projectiles, if whatever we use is whatever formula we use, that will always be displacement.
S is always displacement.
In projectiles.
In everything.
In physics.
In physics. Yeah. You look terribly confused. I suggest you watch the video again, maybe. By the way, if you didn't include this time, you have to wait to hear the sound, then the answer would have been 30.7. So there's a small difference if you don't include the time you have to wait to hear the coin. The reason I did this example was because it's realistic. What I mean is you could do this at home. If you knew how deep it was, and if your friend had a watch, you could throw something up in the air, you could time it, and you could work out how fast you threw it. By using only how much time you have to wait and by knowing how deep the well is. But this is easy to calculate if you have a rope.
Yeah.
You know, rope with a little bucket at the bottom, you can just measure it. Yeah. Let me think, what would I like to do? I think I have two ideas. I think either more of the first lesson or more of the second lesson. More projectile examples or more drag examples. So don't say just yet. Take a few seconds to think about which is more important to you right now, and we can do more of those.